My theme is application delivery and security, scaling and securing the unbounded workspace. And my solution emphasizes on securing the Docker containers. Creating containers in a system helps us utilize the resources in an efficient manner. However, at times, security holes in container configuration can lead to compromised situations. Docker container security plays a crucial role in safeguarding our virtualized services. And as a part of this challenge, I have provided recommendations to tighten the security on containers. So starting off with the solution has been broken down into two different steps, that is, a static and a dynamic analysis part. So as to ensure the security of the container is taken care of, we went ahead with the two-step approach so that all the bases are covered. The static analysis is where we define few procedures to evaluate on the static files, such as the Docker file. Likewise, dynamic analysis is where the procedures or checks are defined to be performed on dynamic objects, such as the images or the containers. Through this two-step approach, we can cover most of the attack surface, where we analyze Docker images even before they are built, and also perform some checks to ensure that they are secure post-image creation. So our approach to the problem statement is to provide a pre-consolidated script composed of checks to determine the strength of the security in view of static and dynamic analysis. We utilize our custom checks for few practices on how to write Docker file along with the help of some open source scripts like Docker Bench Security that checks for dozens of best and common practices that are around for deploying Docker containers in production. As these tests are automated and based on CIS benchmarking, they provide us with the ability to self-assess our Docker hosts and ensure the Docker file is properly written. Furthermore, to make sure the containers are secure even while running, we utilize some open source scanner softwares like Trivy to ensure Docker container images are secure in terms of network ports, vulnerabilities, etc. Some of the measures to secure containers that are highlighted in my script are as follows. We have to make sure the container process are not provided root permissions within containers, as this will give administrative access to your container and host environment. To avoid this, we can make sure to set up a non-root user in your Docker file, including the -user option in your Docker run command. Docker Hub is the official repository Docker uses to store and share and container images. We urge the users to maintain their own repository to ensure security of their images. People usually forget to use the latest tag while using the Docker file access across any base they use. Sometimes they use the old images or bulky images. This increases the attack surface. Hence, we need to keep images clean and try to optimize the Docker file with Docker ignore file usage. Sometimes, Docker daemon defaults to pulling images without checking integrity of the image. We can force integrity checks by ensuring docker_content_trust flag is set. We also make use of Docker Bench Security, which will be used and the script itself. Similarly, few other checks like usage of copy instead of add command, as add command has an additional functionality where the source can be a URL to fetch and extract on container file system. So the add command can be used to fetch some unwanted URL unnecessarily. Hence, Docker documentation also explicitly advises against using the add command. Additionally, add builds an extra image layer, thus we can use curl or wget to download files and can save space. We can also check for recursive copy situations. Passwords, APIs, private keys and other secrets must be never a part of the Docker file. Secrets in Docker file can easily be exposed. Secrets in Docker file can easily be exposed by simple commands like docker history, and once exposed can be exploited by an adversary. We also remove setuid and getuid permissions to ensure proper access control is maintained. We have to make sure update instruction is never present solo on a single line. This is because Docker caches these types of commands and uses the cache every time it builds new container. Finally, adding health checks, restricting network port accessibilities and limiting build data are few more best practices. Out of these health checks, restricting port accessibility, setting resource limits all come under dynamic analysis. Lastly, talking about the future scope and its business viability, this idea can, instead of a pre-consolidated script, can be converted into a product and probably be integrated later into the Docker API itself. This thing can also be integrated into a CI/CD pipeline. So before the container comes into any deployment or production server, these checks, the container are made to go through these checks, so that to make sure the containers are safe to run and might not turn out to be might not have any vulnerabilities later. Furthermore, dynamic analysis can be automated to find common vulnerabilities, like I mentioned before, in terms of keeping it in CI/CD pipelines. And lastly, self-improvement of the security mechanism through different machine learning techniques can be made. Suppose this can help us in terms of checking the usage of the resource usage of the containers, or probably finding some common vulnerabilities which for which any machine learning model can be trained based on the previous existing data. That was it from my side. Thank you.